already seen what are data structures and the use case of stack. With the theoretical knowledge we have, let's try to implement the following use case of stack.
Imagine a set of plates. If the stack gets too high, it might topple. Therefore, in real life, we would likely start a new stack when the previous stack exceeds some threshold. Implement a data structure set of stacks that mimics this. Set of stacks should be composed of several stacks and should create a new stack once the previous stack exceeds capacity. SetOfStacks.push and SetOfStacks.pop should behave identically to a single stack. That is, pop should return the same values as it would return if it were just a single stack.
You may be thinking, without implementing even a single stack, how can we even implement a set of stacks? Here's the trick. In many languages, a stack is built in, and in real life scenarios, there's no actual reason for us to implement a simple stack. Now let's take simple implementation of stack in Java and implement our use case. Now let's get started. We are back at our machine. We'll be using Eclipse as our IDE to implement our data structure. We'll be writing Java code in Eclipse, obviously, and let's get into the programming. And before that, I wanna tell you something about the screen recording in the last video that I've done on Git. I've seen few jitters in the screen recording, and now I've switched to OBS screen recording. It is actually used for game streaming, so I'm hoping this screen recording would be much more smooth. And let me know how's the video is, and if you have any better suggestions for screen recording, comment below. And for now, let's get started.
Now let's start programming by creating our project. Let's name the project as SetOfStacks because our data structure is that. Once the project creation is done, let's create a class and let's name it as app, and we'll make this a starter for our project. This is the main class from where we have to start our code, but right now we do not have a data structure to start. So let's create a new class where we will write all our data structure part. Let's call it as MStack. So this is the class where we write all our data structure related code. So how do we do it? We already know that we have a stack implementation by Java. Okay, and from the problem statement, we know that we need collection of stacks. We'll create array list of stack. So we will have type of stack which is directly imported by our IDE here. So we are getting stack implementation by Java from util java.util, and here we will keep stack can contain of elements of type integer, and let's name this variable as stacks. But let's also initialize our array list here itself. I think it's better to make this access specifier private as always. From the problem statement, we also know that each stack should have certain threshold. Let's take that also as integer, call it as threshold. This declaration of array list here is very restricted because we are not allowing the user to have his own user data type. To make that facility, we have to make this part a generic type. So we'll use a generic variable here. As we are making this generic, we have to make the whole class generic. Let's implement a constructor for our class and make the threshold value be passed by the user. Create the constructor and pass the threshold as parameter and assign it to our class member variable. So I have used this dot threshold to specify that I want to assign our class member variable with the value passed by the user. If I don't keep this here, This means that the local member variable is assigned to the local, which doesn't make any sense. At this stage, our array list do not have any stack objects. At the initialization, we must make sure that in array list there is at least one stack. Add an object of stacks to the stack of type T. Yes, that is generated. And for our purpose, let's print out a statement. Every stack has minimum of 3 operations which are majorly used, that are push, pop and peek. Let's implement push operation now. It takes an argument of type element which we need to enter into our stacks. But how do we push the element? If we have collection of stacks like 3, we have to push the element into our last stack. So I think we need an function which can return the last stack. So let's implement that. Before we implement the push operation, we'll call it as get last stack, and it returns a last stack in our array list. We'll take the index of last stack and return that index stack. As we have a get last stack function, we can easily get the last index stack now. So let's get the reference to the last stack by simply using our function, and we have to push the element into this stack. And is that so? Is that simple? I think we need to check a condition in between. What if the size of the stack reaches the threshold? As per the problem statement, we have to create a new stack and then push the element into that. So let's have that if statement here as well. The last stack dot size, when it is equal to the threshold, we need to make the we need to create a new stack and add this newly created stack into our collection, and then push the element into that stack. MStack class has come to some good shape so that we can actually create the object of it. Let's hold this creating MStack and move to our main and create the object and test our push functionality of our stack. Let's create our stack of type integer and call this as SetOfStacks is equal to new stack, and here, and we'll make the threshold as 2. Let's first run this and see if our constructor is working fine. Yes, MStack is initialized. Let's implement our push operation dot 1 and push 2 and 4. Right now, as our threshold is 2, there need to be 2 stacks in our stacks collection. So to actually see that, we will put a printout statement here and say added and stacks dot size. Yeah, let's run this and test it. Yep. So as you can see, the size of the stacks is 2 now. Now let's continue with our data structure by implementing pop operation as well. Pop operation must return T, and it doesn't take any arguments. So how do we do it? Push operation inserted the element into the last stack. So pop operation should pop the element from the last stack. So let's use the same function that we have written and take the pop element into the popped variable and return this. But what if the size of the stack reaches 0 after the element is pushed? In that case, we must remove the stack of size 0 from the collection. We have to write an if condition here. We'll remove the stack by passing the stack reference. Let's implement peek operation because it is a simple 3-line function. So peek operation, it returns the topmost element in the stack. Let's implement that. It returns an element. It doesn't take any parameters. It returns the topmost element, so it should have the reference to the last stack, and it must return the topmost element. So we will return the topmost element like this. In the last stack we will get the size, and -1 element will give us the last or the topmost element. Let's test our pop and peek operation in our main. Let's do like this. And let's write it once more so that number of stacks will be decreased. Let's print out the topmost element. Let's run the program and check in our console. So first 1 and 2 is added into the first stack, and 3 and 4 will be resulting to create a new stack in the collection. So 3 and 4 will be resulting to size 2, and we will be popping 4, that is the topmost element, and then 3. Then after that the topmost element with the peak, which is returned as 2, which is from the first stack. We have successfully implemented our first data structure set of stacks, which is a collection of stacks, and with some threshold value we have implemented our own push, pop and peek operations. This is a very humble introduction to stack and data structures. In the further upcoming videos we will be looking at more stuff and challenging interview questions which require some data structure to implement that. I'll see you in the next one. Here we go!